So instead of doing all four sides are proportional and all four angles are equal, we have shortcuts. So do you remember the shortcuts that we did back when we were proving congruence? There were 4 of them. Remember the 4 congruence shortcuts that we did? Okay, we had the angle side angle shortcut. We had the side angle side shortcut. We had the side 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 shortcut. And the angle angle side shortcut. So these 4 shortcuts prove that 2 triangles were congruent. Now if you look at your notes today, we only have 3 similarity shortcuts. So the 3 similarity shortcuts are side, side, side. What's the other one? Side, angle, side. And then a new one, which is just angle, angle. So we're looking at 2 you've already used and 1 new one today. Alright, so I'm going to skip past a couple of these things and we'll get to the bulk of the notes here. So, the angle similarity shortcut. I typed it all for you. All you have to do is read and comprehend this. It says, if 2 angles of one triangle are congruent to 2 angles of another triangle, then those 2 triangles are similar. Do we have to know anything about their side lengths? No. If I can prove that it has 2 congruent angles, that is 1 pair of congruent angles, and 2 pairs of congruent angles, what do I know about those 2 triangles? They are similar. So you might see a question that looks like this. 60, 50, are those 2 triangles similar? Why not? Well, how big is the third angle in this triangle?
Oh.
How many degrees are in a triangle?
180.
180. So if I do 180 minus 60 and 50,
70.
that means that this angle has to be 70 degrees.
No, it is not.
Does it have
Oh, yes.
1,
Yeah.
2 sets of congruent angles?
Yeah.
Yes. So why are those 2 triangles similar?
Because they have 2 angles that are...
Because of the angle shortcut. We're trying to skip steps. We did absolutely no proportions. If I can prove that 2 triangles have 2 sets of congruent angles, it proves that those 2 triangles are similar. Right? Side angle side. We did this shortcut with congruence. If 2 triangles, if a pair of corresponding angles is congruent and the sides, including the angle, are proportional, then the triangles are similar. So it has to be side, angle, side, and the angle has to be between the 2 proportional sides. When we did a congruent shortcut, it looked like this. This side was 3, this side was 3, this side was 6, and this side was 6. So it said side, angle, side. Remember that? Today when we do this, it's going to be proportional. So this could be 3, this could be 6, this could be 9, and this could be 18. Are those 2 triangles similar?
No.
Do they have a pair of congruent angles?
Yes.
Yes. So now I have to determine if they have a pair of corresponding proportional sides. So you have to make that life-altering decision. Left over right or right over left? Right over left. So you pick a length from the right triangle, 6, and its corresponding length from the left triangle, 3. And you have to see if the length from the right triangle, you have to see if those two are proportional. So you can check proportionality by simplifying the fraction, by dividing, by converting to a decimal. What is 6 divided by 3? What is 18 divided by 9? So they have a set of proportional sides. They have a congruent included angle. So are those two triangles similar?
Yes.
Yes, by the side angle side similarity shortcut. That's 2/3 of it, guys. And the last one's angle side angle. The angle side angle, or sorry, the side similarity shortcut. You guys loved this one. If you can prove that it has 3 pairs of corresponding sides with proportional side lengths, then these two triangles are similar. Kind of like what we did yesterday. It's going to give you a bunch of numbers. 2, 3, 4, 4, 6, 8. Do we care about angle measurements now? No. We have to figure out, are those two triangles proportional to each other? So, left over right or right over left? Left over right? So we got to do green over green. 2 over 4. We have to do yellow over yellow.
3 over 6.
And we have to do purple over purple.
4 over 8.
So you can reduce the fractions, you can convert to decimals, or you can check cross products. How do y'all want to do it?
Reduce
Reduce the
the fraction.
fractions. So 2/4 is the same as
1/2.
1/2. 3/6 is the same as
3/3.
3/6. 1/2.
Oh,
4/8 is the same as
1/2.
1/2. Are they all the same fraction?
Yeah.
So these two triangles are similar by the side shortcut. So what we're going to do now is we're going to go explore. You're going to open your books and we're going to explore inside of the thing, and we're going to figure out if the triangles are similar. You're going to have to state, are the triangles similar? Is the orange triangle similar to the black triangle? If they are similar, what is the congruence shortcut that proves it? So you're guessing angle.
No.
Yes?
No. Yes.
So I agree. I have an 82-degree angle down here and an 82-degree angle right here. That is one pair of congruent angles. Go ahead, Colby. Angle X. What triangle is angle X in? It's in the top of the orange triangle, and
The bottom.
it's the top of the black triangle. So that's called a shared angle. So I have two sets of congruent angles. So are these two triangles similar?
Yes.
Yes. What shortcut did you use?
Angle.
The angle shortcut. Now we have to write a similarity statement. So remember, you have to say that triangle this is similar to triangle that. And you must name your triangles in the same order. So you can name orange triangle first or black triangle first. It does not matter. XYZ is the black triangle. X, Y, Z. When you name the black triangle, you went from 2 marks to a blank to 1 mark. So you must follow the same order when naming the orange triangle. XVW. 2 marks, blank, 1 mark. They are listed in the same order. How do y'all feel about this? Is it weird? You have 3 shortcuts instead of 4? We're writing similarity statements instead of congruent statements. Oh. Are these two triangles similar? Question.
Yes.
Yes. Okay, what similar or what shortcut are you using to justify that? Okay, we have vertical angles. That lets us know that these two angles are congruent. Perfect. I see vertical angles. I told you guys it was all coming back to this. That was topic 3, vertical angles, the bow tie angles. So right now we have one pair of angles. Are there any side links listed? No, so I'm not going to be able to use side, 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 or side angle, side. What you're justifying is where is the other angle?
What do those things on the little triangles mean on the line?
Oh, that's a great point. What do these little things mean right here? It means that they're parallel. Didn't we do a bunch of stuff with parallel lines and transversals?
Line KG is.
Are you talking about like a bisector or something like that? No, that doesn't. You can't do that, guys. When we have two parallel lines and a heads up, special instructions, and a transversal, what do parallel lines and transversals create? Alternate interior angles. That's something you guys learned almost 2 months ago, and I told you it's going to come back on you. This angle right here is inside the parallel lines, and this angle right here is on their alternate sides of the transversal. They are inside the lines. Those angles are congruent because they are alternate interior angles. Does that allow you to make a similarity statement now? Do you have two pairs of congruent angles? Yes. So are these triangles similar? Yes. Why are they similar? The angle shortcut. Now I have to name the orange triangle and the black triangle in a similarity statement. The hardest part for you guys here was identifying those alternate interior angles. That's something that you're going to see over and over again. So, you want to name the black triangle first or the orange triangle? The black triangle? So name the black triangle. Doesn't matter how you name it. H, K, J. So we went from the 2 to the blank to the dot. So we have to go 2, blank, dot. So what is the name of the orange triangle? HGF. The similarity statement has to be written in the correct order so that you can match up the corresponding angles. What was the hardest part about this one, guys? The transversal part. Okay, this is what I'm trying to teach you guys today. The angle shortcut. But it's the other parts that we're getting stuck on. Okay, let's look at this one. Now look at it. Just look at it. What shortcut do you think that's going to be? Side angle side, because I have a side, an angle, and a side. This one has a side, an angle, and a side. So if I can prove that those two sides are proportional to each other, then I can use the side angle side similarity shortcut. So step number 1, is the angle between the sides? Yes. Are the sides proportional? You have to decide, black over orange or orange over black. Orange over black. It's a pretty tough decision, isn't it? I'll give you guys plenty of time to make that decision. We're going to go orange over black. So pick a side length from the orange triangle. 4. And the corresponding side length from the black triangle. 6. Is that proportional to the other side length from the orange triangle? 6 over the other side length from the black triangle. Definitely a 9 because it's a number. Cool? It's definitely a 9. Okay, but you can't determine proportionality with the letter there. So are those two fractions proportional? Let's do something different today. Let's do this thing called cross products. What is 4 times 9? 36. What is 6 times 6? Are their cross products equal? Yes. So those two shapes are proportional. If you're a simplifying fraction person, you should have got same story. So are those two shapes similar? Yes. Why are they similar? The side angle side shortcut. Because they are similar from the side angle side shortcut, I have to write a similarity statement. I'm going to go ahead and name the orange triangle for you. LMN. Now it's your job to name the black triangle in the same order. QPR. Is that better than the angle shortcut? Is it a little more obvious what's going on there? Yeah? Let's try one more like that. Are these two triangles similar? Maybe? So we're, like someone's guessing side angle side. That's a good guess. But where is the angle that they're sharing? Angle L. Angle L is at the top of the orange triangle, and angle L is at the top of the black triangle. Side angle side. Perfect. So we have to prove that now. So we have to say, we've already said, this side angle side versus this side angle side. So we have to just say, is the left side proportional to the left side, and is the right side proportional to the right side? So let's do orange over black. How long is the left side of the orange triangle? 6. Be careful.
Are you there?
Be careful. How long
Are you there?
is the entire side of the black triangle? Hello. I do. Oh, thank you. Bye. How long is the entire side of the black triangle? This whole piece. 9. Because 3 plus 6
I thought you meant the other side.
equals 9. No, you're good. So I don't want you guys saying 6 over 3. We don't want to do that. It's this length over the whole length. We have to add those two numbers together. So 6 over 9 is the left side. How long is the right side of the orange triangle? The orange triangle.
Okay.
10. And the whole triangle? 15. So I have to check and see if those two things are proportional. How are you going to do it? Cross multiplying, okay? 6 times 15. 90. 10 times 9. 90. Are those the same number? Yes, their cross products are equal. Those two shapes are proportional. So I can say, yes, they are similar. And why are they similar? Side angle side. And then I get to do the similarity shortcut, or the similarity statement. I'm going to go ahead and name the orange triangle for you. K, L, M. I went like this. Boom, boom, boom. It is your job to follow my instructions. I named the black triangle. ELJ. Perfect. Okay, there's two shortcuts down. We have one shortcut to go. What's the last shortcut we haven't talked about yet? The side, side, side shortcut. So, are these two triangles proportional? Or similar? Huh? Yes? Is there any angles marked anywhere in there? No. So you have to say, I think it's going to be the side, side, side shortcut. So what proportions are you going to set up? Are you going to do orange over black or black over orange? Orange over black. Now we're going to have to write this thing called an extended proportion. We have to write all three of them down. And we're going to have to simplify all those fractions to see if they match. So pick a length from the orange side and its corresponding length from the black side. 7 over 21. Does that concern anybody that we're doing a 7 from the left side and a 21 from the right side? Did you notice that it was reflected? See what we did there? We just talked about that, didn't we? Okay, so we chose 7 and 21, that's fine. And then 12 over what? 12 over 30. And then now here's a huge hint. What if you didn't catch that they were reflected? What's a way you can never screw this up? Well, the smallest number over the smallest number. The largest number over the largest number, and the medium-sized number over the medium-sized number. It should always be small over small, medium over medium, large over large. So how do we want to do this? We have three proportions. Is cross products going to work here for us? It can, but it's a lot of work. I recommend simplifying your fractions. So you type in 7 over 21 and hit enter. What does it give you? 1/3. If you type in 12 over 30, what does it give you? 2 over 5? 2 over 5? If you type in 15 over 45, what does it give you? Huh. Now what? It's broken. What are we supposed to do? You just say no. Are they always going to work? So guess what? No. Not similar. They're not similar because this cross product, that fraction doesn't match the rest of them. That's called a counterexample. That's when it doesn't work. It will not always work for you. All right, last one. Who's excited? Just me? Okay. Are there any angles in here anywhere? No. So we're probably going to have to use the side, side, side shortcut.
Wait, what about L?
What about L? Oh. Anybody else see that? So angle L is a shared angle. So you get to choose however you want to do it. Which way would you like to proceed? Do you want to do side angle side, or do you want to do side side side? I'll pick for you. Side side side. Why not, right? So we have to set up 3 proportions. And we have to make sure that they're all correct. I'm going to do orange over black. Tough questions here. How long is this orange piece? 32? I don't see a 32 anywhere up there. Oh, you have to do a little bit of math.
32.
The whole thing's 88, and you take away 56 right here, and you get,
32.
there's where that 32 came from. Thank you, smart people. So, if the orange piece is 32, how long is the entire black piece? 88, yes. Okay, that's the left side. Let's do the right side now. How long is this piece? 52? That was subtraction again. 143 minus 91 is 52. How long is the entire LE, the right side? 143. Okay, well, we've done the left side. We've done the right side. Now we got to do the bottom. How long is the bottom of the orange triangle? Yes. How long is the bottom of the black triangle? Yes. Look at these beautiful fractions. I'm going to grab my calculator. And I'm going to type in I'm going to do 32 divided by 88, and I'm going to put a decimal in there. And it says 0.363636. Or if you just do 32 divided by 88, it gives you the fraction 4/11. Now I'm going to do 52 divided by 143. 4/11. Oh, what am I praying that baby Jesus, the last one's going to be? 4/11. 44 divided by 121. 4/11. Are those two triangles similar? Yes. Why are they similar? The side, side, side. Shortcut. Achievement unlocked. Now I get to write a similarity statement. This triangle is similar to this triangle. I'm going to do the black triangle first because I can. I'm going to say that's triangle DLE. And you must name the orange triangle in the same order. KLM. Man, you guys are smart. How fantastic is this? Just like a lot fantastic, or? I mean, it's so much fun. Let's keep going. Are those two triangles similar? It's nowhere. It's just visual eye candy right now. It's nowhere in your notes. You just get to. Yes.
Are you there?
I'm here. Why are those two triangles similar?
Paper as heel.
I do. Cadence. Cadence. Student services. Student services. Take your stuff. We only got like 3 minutes left. So yes, these are similar. And you said vertical angles, right, Kate? We have a set of vertical angles right here. And we have to either find 2 proportional sides or 1 more congruent angle. The transversal, we have parallel line parallel line, transversal. These two angles are alternate interior angles. That gives me the angle shortcut. So let me clean that up a little bit. Yes. Angle. It's not on your homework, is it?
It is.
Oh, sorry. I'm saying it's the first one on your homework. And then we have to write a similarity statement. Triangle. Who wants to give it a go? EAB. I know, right? Triangle EAB is congruent to no EDC. Because it went 2 marks, blank, 1 mark. It has to go 2 marks, blank, 1 mark. See it? So it has to go 2, 1. Oh, no, wait. Bad Baker, it went 2, blank, 1. So it must go 2. Did I do it right? I was right. Sneaky snakes, you. 2, blank, 1. So it has to go 2, blank, 1. Want to try another one? Yeah? Sure. Uh-oh, SpaghettiOs. Are these two triangles similar? Now, what shortcut do you think you're probably going to use here if there are no side links listed? Okay, so is there any set of congruent angles? Does this make it easier for you guys to see if I color that triangle a different color? N is a shared angle. Huh? You think L and O are the same angle? M and P? They are. Because we have parallel lines. And we have a transversal.
Oh, okay.
These are corresponding angles. Man, I wish I had tried harder or saved my foldable from when we created those last year. You still have your foldable? Alright, get it out! Not right now, because we're almost out of time. So I'll give you guys the rest of that assignment, let you guys practice that, and you'll turn in both tomorrow, because I didn't pick up your homework today.
Wait, so is that one angle?
This one would be, yes, angle, and then you'd have to write
Oh, it's just angle.
just angle. Cool? Good work today, children. I'm proud of you. Now work on your assignment.